Hey guys, this is Pranav. In this video, I'm going to be doing a walkthrough of SAT subject Mathematics Level 2 practice questions from the official College Board website. So I'm going to share my screen. I hope you guys enjoy. Okay. So, before I even begin, I hope you and your loved ones are staying safe. Those of you that are watching this in the future, hopefully, this video still exists, and those of you from 2030 and 2035, I hope you really don't get this reference, which means that we will be okay. But if you do, crap. Okay. Anyways, so I'm going to be doing a request video. A bunch of you requested, some of my students as well, that I do a video on the general scope and the boundaries of what topics and the applications of given concepts are tested on the SAT-2 Subject Math Level 2 test. And the more I thought about it, it became clear to me that instead of me doing an entire video on the exact scope of every topic that comes up, even though that's useful, I think it's better for me to do walkthroughs. And I'll follow up this video by doing walkthroughs of the practice test that you guys can find in the official guide, and some other resources that I can find. But I think doing a walkthrough from the College Board website's 28 initial questions is really, really good. It's a window to kind of see what they're thinking. And I'll wrap up this video on my recommended ways in which you guys can prep for this effectively, right? As from prep books, blah, blah, blah. So I'll definitely, discuss this briefly in the end of the video, and also make a separate video on how to effectively study for this. There are, many different things that I can do, and I'm dying to make videos of, but for this one, let's just focus on, the thing I have to the left. If you go to the College Board website, you will see that on the initial info page for SAT Math Level 2, you will see, different things. Definitely read through all these tabs: anticipated skills, recommended preparation, topics, which categorizes what the test is all about, and practice resources. So once you click on practice resources, you can practice with 28 of these. And in fact, you can actually view the correct answer and explanations through here. But what I found is the way that I view, based on my experience with prepping students for this test, I can streamline this process for you guys significantly. I hope you guys, will benefit from at least a starting video, even though you have the explanations from the website. So what I'm going to do is go through these questions, and anytime I have an opportunity to make a surrounding point or give you a bird's eye view on any given concept and the scope at which it's tested, I will elaborate on that. I will be working on, this document here, and at the end, I will definitely save this as a PDF and upload it, as well as the video. I don't have any. This is the first video I'm ever making for this, general purpose. So I will find a way to give you all the surrounding supporting resources that go along with this video. All right, so let's quickly mention. I'm going to start with I'm going to start with giving you a general scope of the test. Obviously, this test is, completely different in what it's trying to really test you on, and it's philosophy than SAT, general SAT ones. Not level 1, I mean, out of 1600, the SAT test. This one is for you to display your knowledge and interests in mathematics. There is no calculus on this test, even though some kids argue always with me that Mr. Gupta, calculus is very useful here and blah, blah, blah. But I will fight them to death that you do not need calculus. Maybe you can get lucky and then find a quick application of the L'Hopital's rule. But, this time that you spend and trying to hunt for calculus ways of doing questions is much longer than the time that you will save in the off chance that you find a question where you can apply it. So don't forget about calculus. So up until, let's say, pre-calculus, even some topics in pre-calc are not even fair game on this test. So, so the scope ends until pre-calc. Obviously, the maximum score is 800. And in terms of raw score on this test, I would say on average, 55. Whoa. I wish I can get a 55. 45 out of 50. There are 50 questions. Will get you a perfect score. By the way, guys, this is one take. I'm too lazy to make different takes and edit and stuff. So I'm just going to publish this in one take. So I apologize if I say something wrong. I'm sure there are going to be a few things and corrections that I would have to make, and it's easier for me to make them through comments. So I hope I don't, but yeah, guys, understand that this is one take. I'm doing this from the top this document, and let's see how it goes. All right, so 45 is going to give you a raw score of 50. Now, the raw score is not just the number of incorrect. The raw score is number of blanks, right? Plus 1/4 number of incorrect attempted questions. So you do get a penalty for guessing. Well, I don't want to say guessing, but attempting questions incorrectly. And 50 minus that is going to be your raw score. So in some tests, you can actually leave 5 blank, and if you get everything right on the remaining 45, you'll get a perfect score. I've seen curves that go as low as 43, and then maybe I'm sure there have been where 46 was the cutoff line for a perfect score. Second thing I want to mention is this is a highly specialized test. Don't take it just because you feel like, oh, I'm taking subject level 2, I must be good at math. No. The converse should hold true, right? So just because you want to show off your skills in math does not mean you're actually good at math. So you got to really prepare for this test. And in terms of, just to give you an idea on how specialized this test is, and it definitely carries a lot of weight in the college applications for what it's worth in terms of subject testing. And it's one of the more popular subject tests that students take. I think in 2019, on the May, and June was very similar as well, on the May and the June official test, and 800. Why do I keep messing up the score? Great start. And 800 was 79 percentile. Think about that for a second. So when you compare this with other ones like SAT subject literature, getting an 800 in SAT subject literature test is godly, right? It will put you in comfortably the mid 90 to high 90 percentile. So getting a perfect score and that being the 79th percentile means that students that take this test really, really are specialized. They really know what they're doing. They want to display their interest and their expertise in this subject matter. So don't take it lightly. You're taking this test with a lot of highly competent, prepared students, almost 20% of which will end up getting a perfect score. I don't see why this will not be true, on this test as well. All right, so let's begin. I'm going to give you a very general view of the scope. Think of all 50 questions being able to be put into one of the 4 buckets. So the first one I will say is pre-algebra. And very simpler algebra and numbers and operation topics will fall under this guy here, right? Then the second bucket is going to be algebra and functions. And the third one obviously is geometry. It's going to cover all the different topics that you've learned through many, many years of high school and even middle school. So this is a very comprehensive test. And then the fourth one is going to be data analysis, probability, and statistics. Now, in terms of the coverage level, these are the keys. They will make up almost 80% of the entire test. Algebra and functions and geometry. Now you can go deeper into the scope of algebra and functions, what are the subtopics, blah, blah, blah. And that's something I'm going to be highlighting as we go through the different questions. So don't, get it twisted. I think these two are going to be the big boys that you really have to master. And trigonometry, by the way, I'm filing it, or College Board files it under, the trig, the one we love the most, under geometry. Actually, I find that at the higher levels, trig is not going to be the issue. It's going to be three-dimensional geometry that a lot of students struggle with. Okay, so let's begin. By the way, I don't think I'm going to be able to go over all 28. I'm just going to keep this video under 30 minutes, hopefully. So if you're at question 5, then I will never make a video again. I'm the horrible video maker. If you're at question 28, great. If you're at question 17, then I'll stop there. I don't want to keep rambling on. So yeah, so expect the length or the question coverage of this video to be a function of my patience and my enjoyment, for your enjoyment, I guess. But wherever we stop, if it's not to number 28, I'm going to be making a follow-up video so I can finish everything off. All right, so the first one, we have what is the distance between the points -3, 6, and 7 to -1 and 4, okay? So you want the distance. Guys, this is in 3 dimensions. You have a triplet XYZ, right? So it's not just the X and the Y axis, you have a Z axis somewhere here. And the derivation of the Pythagorean theorem in 2 dimensions, you all know the formula. It's x2 minus x1 squared plus y2 minus y1 squared, yada, yada, yada. In 3 dimensions, you can actually even derive it. It's just an added term of z2 minus z1 squared. So distance between any 2 points can be found by just this extended distance formula. So this is x1, y1, z1. This could be x2, y2, z2. So distance, again, I'm not going to be going over the questions like every little step. I don't have a calculator in front of me. So what I'm going to do is I'm going to be just giving you the general, point you to the right direction, right? So follow along. So distance is going to be, x2 minus x1, or x1, it doesn't matter the order, right? x1 minus x2, which is 5 squared, y1 minus y2, just -7 squared, and then 4 minus 7, which is -3 squared, okay? Which is 25 plus 49 plus 9, which is square root of 74, right? Square root of 74, well, it shows that it's D. Okay. Not 74. So 75, 83. So it's 9.11. All right. Let's keep going. All right. If the function f of x, obviously the previous question was filed under geometry, right? And it would be coordinate geometry. What is the value of f of x? What does it approach when x approaches or gets infinitely larger? So basically, x approaches infinite. Guys, this is a limit question. It's a limit question that falls under algebra and functions. This is perfect. So I'm going to show you, give you the general scope of limit questions quickly. All the limit questions that have come up on the test. So the idea of a limit is finding what, I'm sure you guys have heard of or seen this notation. If you haven't, that's okay. It's a very conceptual idea. So the limit of some function when x approaches some number simply means what does the y value of the function approach when x becomes infinitely closer to that number. It does not have to become that number, but it has to get infinitely closer to that number, right? So on the SAT Level 2 math test, the scope is number 1. You will see questions where you want to find as x approaches infinite or x approaches some finite value. It could be anything, 1, 2, 3, 4, 5. And also, third one is x approaches infinite or finite. I'll explain quickly why I separated 1 and 2 from 3. X approaches infinite, the function given will be rational. X approaches a finite value, the function that's given is rational. And x approaches infinite or finite, the third question type will be when x approaches infinite or some finite value where the function is non-rational. Even though these are not as common as these two. So whenever you see a limit question, right, a lot of times, it's very common, more often than not, you will be given a rational function that you're dealing with. And you will be asked to find the limit of the function as x approaches infinite or x approaches a finite value. You can do this question, guys, in 5 seconds if you realize what's going on. We already know as x approaches infinite of this function, the answer has to be 3 over 2. Now, I said we already know, so let me elaborate a little bit more. For questions where you're given a rational function, rational simply means that you have variable denominator. And if you have a variable denominator, then you have the possibility of having vertical and horizontal asymptotes. So rational functions, look, this is just an example. They may have vertical and horizontal asymptotes, and they have different behaviors. So this is an example of a rational function, some function g, let's call it, right? Think about it. The interpretation of finding the y value when x approaches infinite is same as the idea of a horizontal asymptote. So anytime x is approaching infinite of a rational function, you're dealing with a horizontal asymptote question. If x approaches a finite value, so maybe let's say this one. Now, College Board is not interesting to them to just ask you to find what is the y value at this input, right? There's nothing interesting going on. They'll try to throw you off, and they will be testing you on the idea of a whole, okay? I know this explanation is taking a very long time, but I'm trying to give you like the surrounding ideas, the entire scope of this type of topic and how it presents itself. So for x approaching infinity in this question, you want the limit as x approaches infinity of 3x plus 12 over 2x minus 12. And if you recall, then the horizontal asymptote has 3 cases. The first one is if the degree of top is equal to degree of bottom, is the ratio of the leading coefficients. That is going to be the horizontal asymptote if degree of top is equal to degree of bottom. Here, the degrees are the same. So y is equal to 3 over 2, or the ratio of the leading coefficients is going to be my answer. Quickly, even though we haven't applied it, degree of top is bigger than degree of bottom. You don't have any horizontal asymptotes. There's a special case where if it's 1 more than the bottom, then you have a slant asymptote, but at the same time, the slanted line is not horizontal. So technically, there's no horizontal asymptote. Then degree of top is less than degree of bottom, then You have y equals 0 or the x-axis, right? Now quickly, let me give an example of the second question type. So they will say limit as, I don't know, x approaches 2 of x squared minus 4 over x minus 2. Now, if you try to plug in 2 here, you will realize you get 0 over 0. This is a pretty decent sign in math, if you're comfortable with calculus at this point, 1, 2, 3, 4, whatever, right? That math is screaming at you to stop it and then do something different. So what you want to do is, it seems like at 2 you have a vertical asymptote. That's where the bottom is 0, right? You don't. Because if I factor out the top, they cancel, giving me x plus 2. So all of a sudden, what happened is the factor canceled. That was problematic to begin with. And when I plug in 2, I will get 4 as my answer. So what does that mean? The answer is 4, right? But it does not mean that it's okay now for x to be 2. Where initially it seemed like there was a vertical asymptote at 2, turned out to be a hole. So whenever factors cancel, they will manifest themselves or itself as a hole and not a vertical asymptote. Nevertheless, it's still going to be part of the restricted domain or restricted part of a domain. So just because it canceled does not mean it's fair game. And quickly, my advice on how to handle number 3 is plug in a close value. So they may say something like, what's the limit as x approaches 0 of sine of x over x? I don't remember seeing a question like that, but if they do, plug in 0.001, right? Just do something reasonable. If the limit is approaching 0, just don't plug in 5. All right, let's move on. Actually, I should give you the answer. So it's 3 over 2. Number 3. God, this is pretty fun for me. I can ramble on for make a 7-hour video. X minus 2 is a factor of x cubed plus k x squared plus 12x minus 8. The quickest way to do it is not to try to factor, but know that given a factor, x minus 2, that means x equals 2 is a root, a 0, or the x-intercept. In other words, if I plugged in 2 in for this function, I would expect a y value of 0. And then you can solve it out, and you should get k to be, let's see, 24 minus 8, 16, blah, 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 -6. Okay. Let's see. I'm trying to decide in my head if I want to expand on this a little bit. Obviously, it's algebra and function domain, but this is related to also the concept of the remainder theorem. Like they will say, if you were to divide this polynomial by this factor and end up getting a remainder of 5, then what would be the value of k? In that case, you would have to plug in 2 for x and set it equal to 5. This is a connection between the evaluation of a polynomial at any given input and the remainder when you divide that polynomial by a linear factor corresponding with that root. But you know what, it's not practical for me to give you 100% of the scope for every question. All right, let's do number 4. Allison deposits $500 into a new savings account that earns 5% interest compounded annually. If Allison makes no additional withdrawals or deposits, how many years will it take for the amount to double? Okay. So we're dealing with an exponential model because we're dealing with compound interest. So you're starting with 500. That's the initial value. And the initial amount is being compounded meaning you're getting a 5% interest, or you are multiplying the amount by 1.05 year after year until you get to an amount that is double that. So the final value has to be 1,000. And you want to find out, because it's every year, annually, how long will it take? So how long will it take for it to double? And then we're going to solve this equation, right? So we can divide by 500 and get 2 is equal to 1.05 times raised to the t power. Guys, anytime you have a variable as an exponent, it's a pretty decent policy, a reasonable thing in most cases to assume that logs are involved, okay? Logs and natural logs were the same thing, right? So the reason logs are really powerful in dealing with variable exponents is because by one of the properties of logs, log base a of x to the y is equal to y times log base a of x. They're very effective tools in bringing the exponent down to the numerator so you can solve for it properly. So I'm going to take log of both sides. Now, if the e's were involved, I would take natural log. But in this case, just take log. It's your preference. If you want to take natural log here, I don't care. It's the same exact thing. So it's going to become log of 2 is equal to t times log of 1.05. And t is going to be log of 1.05 over log of 2. Okay. Sorry, the other way around. Otherwise, the answer would be less than 0. All right, I don't know what this is. You can just plug into the calculator. So it turns out to be B. All right, next one. Number 5, vectors. Students hate this idea. But as a physics major or ex-physics major, I love me some vectors. The scope of vectors is actually pretty limited. You just have to know what it means and then find the basic resultants using given the coordinates. And it makes it also all that much easier given that it's centered out the origin. So a vector is a quantity that has magnitude and a direction, right? It's different than a scalar quantity. So if I go to the store and buy 7 apples and you watching, one of you buys 10 apples, how many apples do we buy together? 17, right? It's pretty straightforward. But then there's no direction associated with those quantities, so we can simply add and subtract just by adding and subtracting the magnitudes of the things that we're operating on, right? In the case of a vector, it's completely different. If a plane is going in this direction at some speed, and there's some wind that is in this direction, relatively speaking, in this direction, then basically we can say that the resulting speed of the plane is not A and B, right? The wind is not helping it entirely. Had the wind been on its tail in the same exact direction, then we can say the resulting plane or speed of the plane is going to be the sum of vectors A and B because they are going in the same direction, right? If the direction is different, then it's not as straightforward as us just adding the two magnitudes. So in case of a vector, quantities where direction is important and can affect the operating principles, then direction matters. So the way to find the resultant is to do the tip to tail method, meaning take this vector and line up its tail on the tip of the first one. And the resultant is going to be that, okay? By the way, this absolute value simply means the actual magnitude. So here, if you want, OB is subtracted from OA. Whatever this is being subtracted from OA, meaning I'm adding OA and negative OB. Negative OB, I can think of it as having -8, -4. So if I add this guy to this guy using the tip to tail method, I'm going to get something like that. You can actually, this is just for visualization purposes. You can use their coordinates. OA minus OB is going to be 4, 3 minus 8, 4, which is going to give me -4, -1. So that is going to be what we call the coordinates with respect to the origin of that resulting vector. And the magnitude of, or the length of the resulting vector, we can use the Pythagorean theorem and find it, which is going to be the square root of 17, or square root of 16 plus 1. So that is going to be my answer. It has to be a little bit more than 4. All right, question 6. Jesus, we're almost 30 minutes in. Probably might be more than 30 minutes in. Okay, guess I will have to break this into 2 videos. In the xy plane, what is the area of the triangle whose vertices are? Obviously a geometry question. Okay, I'm going to leave this point alone. Who cares? My brain is not working. What is going on? So 2 root 10 and 5, 0. Okay, and you want the area of this triangle. Area is 1/2 base times height. This is pretty straightforward because we're given, we can think of this to be the base. It doesn't have to be, guys. You can use this or this to be the base, but why would you, right? You have a perfectly horizontal length. So the base is 5 minus square root of 2, and you multiply by this height here, which is square root of 10. And just use your calculators, and that is going to be the answer. So this is what, 1.4. That's going to be 3.6. Square root of 10 is about a little bit about 3, and then a little bit over 3. So you're dealing with something over 10, and half of that. I think the most reasonable answer should probably be B. Yeah. All right, 7. A right circular cylinder has a radius of 3 and a height of 3. This will be 3-dimensional geometry. So a right circular cylinder at a radius of 3 and a height of 3. What is the maximum possible straight line distance between A and B if A and B are 2 points on the surface? If I take A and B to be any 2 points on the surface, so I can have A to be here and B to be here. Guys, for 3-dimensional geometry questions on this test, I always recommend students to visualize it and draw it out. In future videos and when you start really preparing for this test, you will see that a lot of them are very logical. Like they will say, what are the possible intersections of a plane and a cone, or what are the possible intersections are of a cube and a cylinder, or 2 spheres, blah, blah, blah. So try to draw it out. It'll give you a lot of insight into what's going on. So I want to pick 2 random points. here and here, and let's say these two, that's the distance between A and B. Now, is that the maximum possible distance? It doesn't seem it, because I can pull this point a little bit further off to the edge, right? And if you play around with it a little bit more, like maybe we can pick on the two bases, that could be A and B, but again, you can slide this point off to the left a little bit, and without too much trouble, and upon further experimentation, you should be able to tell that the largest distance is going to be its space diagonal. So that's going to be the largest distance. And we can find its value by using the Pythagorean theorem. So the space diagonal is square root of 36 plus 9, or square root of 45, which is going to be 3 square root of 5. So the answer is B. All right, another geometry question. There's actually another main difference between normal SATs and SAT subject math level 2. Believe it or not, the normal SATs, they don't care about geometry. And you know, it's very heavily represented here. Now, when I say that they don't care, they're not going to put 0 questions, but it's actually under a domain specified as additional topics, which only is represented by 6 questions. So out of 58 questions, you're not going to see more than 4 of geometry. So yeah, these are completely different tests in my opinion. But if you have a bias against geometry, don't like it for whatever reason, then this test is probably going to give you a little bit of trouble. All right. In the figure above, AB is equal to BC, and the measure of angle C is 40. What is the value of X? All right, AB is equal to BC. We're dealing with an isosceles triangle. That means this is 10. Also, the base angles are congruent, and C is 40. So that's 40, making this 100 degrees. Right? It's an isosceles triangle, and that is the vertex angle, and the base angles are congruent. You want to find the value of X. Okay, there are a few ways of doing it. One way is you can definitely use law of sines. Law of sines says the ratio between the sine of any angle and the length opposite to it is constant in any given triangle. That's law of sines. It's a must know for this test. You have to know this formula. They will not give it to you as a note. So to find X, we can take this pair of opposite angles and sides. The answer is just going to be this guy, right? Okay. So you can just plug this into the calculator and see what this turns out to be. Let's see. Yeah, 15.3. Another way to do it would have been because you're dealing with the isosceles triangle. A lot of times, guys, if you're dealing with an isosceles triangle and finding a missing length given the angles, you can use SOHCAHTOA, right? If I just cut this right down the middle, then that's X over 2. That's the height. And it doesn't matter the height, right? It bisects the base basically. That's the actual theorem. So given this 40, we can say cosine of 40 degrees is, you know, what I'm going to call this Y. This segment over 10, Y is 10 times cosine of 40 degrees, and then double it because we're dealing with this segment, which is 2y. So it's going to be 20 times cosine of 40 degrees. Okay. Okay. Should I keep going? Yeah, let's do it. I'm actually having fun. Like, it's not tiring for me at all. It's pretty good. The reason for me to not make a long video is, you know, I know you kids, you know, your attention span isn't always the greatest on average. So bite size. All right, guys. You want to find what's the difference between the maximum and the minimum values. There are just some questions on this test, very few, that must require a calculator. And this is one of them. Don't even bother trying to graph it out, you know, by picking the endpoints, -2 and 3, because you really cannot predict its behavior. I mean, if you use the Descartes rule of sign, you can use the rational zero theorem, the factor theorem, and try to really get the number of the terms it has, the roots and stuff. But that alone will take you several minutes, if not more than that, right? So the practical approach here is to use a calculator. It's very hard to determine the behavior of a cubic in a given window. So I would just graph it. Let's see if we can. I'm trying to pull it up. Okay, window. So I can say is y is equal to all right, guys. So it's a window from -2 to 3. So the highest point is 2.052, and the lowest one is -1.015. So the difference between the maximum and the minimum should be about 3.06, right? It's 2.052 and -1.015. Okay, question 10. Suppose the graph of -x squared is translated 3 units to the left and 1 unit up, and you get the resulting graph of g of x. What is the resulting value of g of -1.6? All right, guys. This is transformations. So transformations of functions, there are 4 translations, which is up, down, left, and right. I just bless you guys. So if I have f of x, and then I replace every input x with x plus a, that means actually it's easier for me to write it out first and then use a different color. So x minus a all right. What do I pick? This one is moving left A units. This one is moving right A units. This one is moving up A units. It's easier to understand, right? If I just add a number, a constant value to the entire function, every y value is getting pushed up by A units. And likewise, as everything is getting pushed down by A units. Then we have our f of x. If I multiply the entire function by -1, or f of x, and if I replace each input by -x. So these are our famous reflections. So this is reflection about the x-axis, and that's reflection of that y. And I guess I should mention that f of x to negative f of negative x, it's a reflection about the x and the y, and we call it a reflection about the origin. Now, there are other miscellaneous, I guess, transformation weird ones that always also pop up on the test. So, for example, this would be miscellaneous. F of x to absolute value of f of x. F of x to f of absolute value of x. So stuff like these miscellaneous ones. And the way they expect you to handle this is by your understanding, your intuition when it comes to function in the graphs, as opposed to really memorizing what they really do. Okay. But anyways, so using these transformations, I can rewrite f of x into g of x based on these. So moving left means x plus 3 squared up 1 means plus 1. So that's the function that is that represents g of x. Now you're finding g of negative 1.6. Just plug in 1.6 here. So negative 1.6 plus 3 squared plus 1. That's going to be 1.4 squared plus 1, and you will get your answer. So it should be obviously negative, and oops, yeah, negative 0.96. All right, it's getting late. All right, number 11. All right, this is sequences and series. That's what it falls under. So this would be followed under the fourth bucket if you refer back to the first page. And it would be, the subtopic would be discrete math or sequences. And so A sub n, the notation means it is the value of the nth term. That's how this is being indexed. So the value of the nth term is equal to the value of the term before. So with respect to n minus 1 is the term before, and n minus 2 is the value of 2 terms before. So relatively speaking, this is a formula that gives you any given term value in terms of some terms before and after it, right? So this is called a recursive sequence. So given 2 and 1, I can find what a sub 3 is, because a sub 3 is equal to a sub n minus 1. So I'm making n to be 3. N minus 1 is a sub 2 plus 2 times a sub 1. That's what a sub 3 is, which is going to be a sub 2, which is 1, plus 2 times 0, or the answer is 1. Now, generating a sub 4 is not possible because I now know the value of a sub 3 and a sub 2. So a sub 4 is likewise a sub 3 plus 2 times a sub 2. Okay? So a sub 3 is going to be 1 plus 2 times 1, which is going to be 3. Now a sub 5 is a sub 4 plus 2 a sub 3. I can fast forward that, so it's going to be 3 plus 2 times 1, which is 5, and a sub 6 is going to be 5 plus a sub 3, a sub 4, which is going to be 2 times 3, which is 6, which is 11. So the answer is 11. Another geometry. Geez, what's going on with geometry, huh? This is what number 12, yeah. Like I said, try to visualize. I don't know what this question says at this point. Let's see. The diameter and the height of a right circular cylinder are equal. Okay. So look at this beautiful little cylinder. Wait till I draw a circle for you guys. All right. The volume of the cylinder is 2. The volume of a cylinder, so if this is R, that's the diameter, so the height is 2R, which is equal to the diameter, is pi R squared times the height. And we want the height of the cylinder. So let's get R in terms of what the height is. So radius is going to be, if this is H, R is H divided by 2. So radius is H divided by 2 squared times H. So 2 is pi times H squared over 4 times H, or H cubed is 8 over pi. And just use your calculators. And the height is going to be the cube root of 8 over pi. So the answer is going to be, let's see, well, 8 over 3 is going to be a little bit less than 3, so the 2.8, let's say cube root 2.8 cannot be C, D, and E, between A and B. So it's A. That's the answer. All right, 13. Guys, I should be ending soon, maybe after this. Well, 13 is an unlucky number for me, so we must go on and do 14. Okay, so there are many ways of going about it. First approach is we can find what this angle is going to be. Use your calculator and find the inverse sine of 0.57. And once you get this, then plug it in to sine of pi minus theta, and then get its value. That's one way of doing it. And if you're comfortable with using a calculator quickly, this is probably going to be one of the more efficient approaches. But also, some of you maybe, especially in if you go to a magnet school and your curriculum is very advanced, in some curriculums in pre-calculus or whatever they label the course, in analysis courses, they will teach you a bunch of these identities, right? Some of which I'm sure you know. For example, sine of pi over 2 minus theta is cosine of theta, and vice versa. Cosine of pi minus 2 minus theta is sine of theta. This is called the cofunction identity. My professional advice: memorize this and do not memorize any of the other ones. So you can have many different identities for every different trig function that are this form. Okay, so you can have, for example, cosine of 3 pi over 2 plus theta, and you can have, tangent of 2 pi minus theta. As long as you take one of the quadrant angles and then add and subtract an angle, they're always equal to, or you can write them as some trig function in terms of some other trig function. That's what makes it an identity, right? But only memorize this. Do not waste your brain space memorizing any of these, okay? Second, some people think that you really have to memorize the angle sum and difference formula on this test? I don't think so. I do not think you have, well, should be a little bit more confident, right? I know you do not need to memorize them. So don't waste your brain space memorizing the sums and difference formulas. In my next video or one of my other ones, I will definitely highlight all of the trig identities that you must memorize, and just memorize those, and rest you can just put it to the side. You don't have to worry about it. But I want to show you a way to visualize. This is actually the way to do it. That's the most standard. But to give you a deeper insight, I'm going to show you how you can visualize and prove this identity in less than 15 seconds once you get really quick with it. That's why I say, even in school, if you're doing these identities, don't memorize them. You can derive them on the spot using the technique I'm about to show you. So we're trying to prove what sine of pi minus theta is equal to in terms of some other trig function. So I'm going to draw a unit circle. To see what this is equal to, what you want to do is just pick a random acute angle in quadrant 1 and call this theta. So specify some angle theta, and then with however you make theta, let's now find or draw pi minus theta, which is obviously going to be, that's pi. Just take theta away from pi. So it's going to be something like that. That's pi minus theta. I just took this angle away from pi. I'm trying to prove what is the value of sine of pi minus theta. Now, if you remember, sine in the context of a unit circle is always going to be the y value of that angle, right? And cosine is synonymous with the x coordinate. So sine of pi minus theta is going to be this length here. It's the y value of this angle. Now ask yourself, with respect to theta, which length has equal magnitude as this guy, this one, which is sine of theta. So they must be equal. So in this case, the answer is 0.57. Right? So that's how you can derive it in real time in 15 seconds once you get really comfortable with it. Just draw the angle, find the angle, the other angle, right? Whatever is 3 pi over 2 minus pi theta, blah, blah, blah. And then compare the segments in question and see which one's same. So sometimes you'll have to make it negative depending on which direction it's going, but you should be able to figure it out once you play around with it a little bit more. All right, now let's end with 14. Parametrics. Guys, I hope this is not too boring for you guys. I know it's kind of weird to not weird, but not as interesting to watch a long ass video about math questions, but especially with someone with such a dry personality like myself. But I hope you guys are having fun. All right. A line has parametric equations. X is equal to 5 plus t. Y is equal to 7 plus t, where t is a parameter. Just a fancy way of saying that a parametric is anything where x and y, which are the independent and the dependent variable, are written as a function of a third variable, okay? And you want to find the slope of the line. Now, on this test, anytime you're given parametric equations with some parameter, if t or some other variable is a parameter, use substitution. So I'm going to solve for t and get x minus 5 and y minus 7 So x minus 5 is equal to y minus 7. You want the slope. So the equation is y is equal to x plus 2. And the slope has to be 1. The scope of, oh, that hurts my eyes. The scope of parametric equations is this. I'll give you the entire scope of parametric equations. First one, you're going to be given x and y as a function of most commonly t. But it could be, x and y as a function of w. My point is, if it's some other variable, a through whatever, every Greek letter, whatever, right? Then you can simply use substitution by solving for that variable and then setting the two sides or two equations equal to each other and relating x and y. That's always going to be the play when x is given to you in terms of a parameter and y is given to you in terms of parameter that is t or some other variable. Then the second question type, there are only two question types. The second question type is x and y are given to you as a function of theta, where theta represents some angle and there are trig functions involved. So in that case, you have to use trig identities. Okay, for example, they can say x is equal to 2 sine theta, y is equal to 2 cosine theta. And you have to find the relationship between x and y. Do not divide by 2 and take the inverse sign and isolate this guy here. Rather, keep it as sine and cosine and use the identity. So x over 2 is sine theta, y over 2 is cosine theta, and then we can use the identity sine squared theta plus cosine squared theta is equal to 1. If I reference back to what I was saying earlier, this is a must know. You have to know this Pythagorean identity, and sine squared is x squared over 4 plus cosine squared is y squared over 4 is equal to 1. Multiply everything by 4 and you get x squared plus y squared is equal to 4. We're dealing with a circle, right? So that's a common question type or example of a question type of the parameter domain, parametrics domain. You can also have, well, a few points I want to make before I end this video. It might almost be an hour long. It's like a movie. So we're watching a movie. Yeah. If these numbers were different, so x is a sine theta, y is b cosine theta, where a is not equal to b, you will end up with an ellipse. If next point is if x was in terms of other trig functions, so 2 secant theta y is 5 tangent theta, this will result eventually because you have to use the other two identities that are derived from this. I don't want to waste too much time, but I'll show you how to get them. So basically divide this one, this guy, by sine squared, you will get the second one. If you divide the entire equation by cosine squared, you get the third one. Then you will end up with a hyperbola. Okay, so sine and cosine, depending on what the coefficient is, are going to give you the ellipse or circle, and then the other one, otherwise you will get a hyperbola. And in terms of parabola, if you're keeping track of your conics, will come about when you get this, especially when x or the parameter, one of them is being squared, or x is being squared, or y. Okay, I know I said that I was gonna, wrap it up with some study tips on how to study. I think I completely mismanaged, or not mismanaged, but like didn't understand the pace of these videos. Maybe I'm explaining too slow. Just let me know in the comments, like, just be honest. Like I would love some constructive criticism if I'm being a little bit too slow, because I don't want to make an hour-long videos for the rest of my life. Like I just want to keep it, 8 to 10 minutes, and maybe I start editing them to shorten them out. But I don't know. I would much rather just do one giant take, upload it for you guys, and you guys can just watch it. I don't really have time to like do all this editing stuff. Maybe I'll put an intro or something. I don't know. We'll see. But yeah, guys, that's the thing. And this document that I have, I will save it, and then I'll go ahead and yeah, give you guys access to this wherever I post a video, whenever I do. Oh, guys, a great question. Should we start again? No. It's almost 10:30. Okay. All right, guys. Thank you for watching my video, and I hope you learned a few things. I try to give you like a little bit insight on how to think about different question types. If you have any comments on what kind of videos that you would want me to make, I can basically make any math video, like anything from elementary school topics to college topics, right? So my boundary would be, grade 1, which I really don't want to make, guys. Please do not recommend me to make you how to add and subtract. I don't even know. Like, I think the hardest math level to teach is elementary school, effectively. So shout out to all the elementary school teachers. I have a lot of respect for you. I really would prefer making at the high school level, whether it's standardized testing or not. It could be school enrichment. So it could be anything, geometry, calc, pre-calc, or college level. I can make Calc 1, Calc 2, discrete math, probability, complex analysis, which I haven't done in a very long time, so that might require a lot of prep. So I would really, really prefer standardized testing when it comes to math, ACT, whatever, AP Calc, whatever you guys have, right? So send me some suggestions. I'll work through some of them. And yeah, I hope you guys had fun watching this video, if that's possible. And I will see you guys soon. All right, stay safe. Bye.